So going back to this graph here, we see that assuming that the irradiance is constant, the higher the frequency, the more photocurrent you get. So how does that work? Well, think about what's going on at the surface of the cathode. Here's our electron. Here's our photons coming in here. That photon has two jobs to do. It firstly has to release the electron from the metal surface, and then secondly, it will actually give it some kinetic energy so that it can actually move in that direction there. So if we take the incident photon energy, which if it's got a photon of equals HF, then HF is got to do two jobs. So it's got to be equal to the energy needed to release the electron, which is something called the work function, which is the threshold frequency times Planck's constant, and then it also provides the actual kinetic energy of the electron which is emitted, so the extra there. So if we represent that as a sort of energy transfer diagram here, here's HF, that's the photon energy, and it does two things. Firstly, it releases the electron with the work function, and second thing is that it will give it some kinetic energy with anything that's left over. And that's why with just on the threshold frequency there was virtually no photocurrent, because they didn't have enough kinetic energy to make it to the anode, even with the electric field, the applied field. But the more frequency, the more kinetic energy, and so the more chances of getting to the anode. So the SQA has these two equations on your formula sheet like this. That's the photon energy in joules. That's Planck's constant, 6.63 times 10 to the minus 34 joules seconds. That's the frequency of a photon in hertz. That's the kinetic energy, half mv squared for the electron that's emitted. That would be in joules. Again, that's the photon energy. That again is also Planck's constant, and that would be the threshold frequency. And you're given both of those, and you will be able to expect it to be able to use them in calculations, as you will be doing in just a moment.